And these are all the articles and studies that have been done by the government showing the percentages of the chemically sensitive in the population. If you were in the Gulf War, it's 15%, but you were deployed in the Gulf War and you went over, it's 30%. Elderly, it's 30%, 15% to 20% in the average family practice office. And this is using Claudia Miller's Queasy scale oftentimes. Okay, so I've sort of touched on this, but some of the basic areas that are most significantly, talked about in lectures that I give are mold toxicity, EMF sensitivity, chemical sensitivity, all making dysautonomia worse, which now you're an expert in this neurologic thing that makes the heart go fast and the blood pool in the legs and they can't stand up. And then I learned about oral galvanism. So, side issue, I was cured when some guy took my crown out. So I had mold in a bad house in California, and then I had a crown put in, and the two metals touching in the crown, the amalgam and gold, covered with a white porcelain thing, it was creating a current. So they took it out. I didn't believe anything, of course, because I was, just a traditional physician, and I was cured. I was like, oh, the chemical sensitivity got a lot better. I could touch the computer and use the phone. All my EMF sensitivity went away, and the medications for slowing the heart rate, I didn't need them anymore. So the total load of things affecting the person is what counts. Everybody will be different.
Okay. All right, here we're going into using airborne fungal spores to assess indoor environments. All right, I want to demonstrate that standard methods for assessing environmental data apply to mold, that is microbials. The methods can extract higher quality information than professional judgment, and that these methods are really simple to learn and implement. I got Jack Clausen up and running fully, completely, just emailing back and forth in one weekend, and he was up and running. Okay, that's just through emails. All right, concentration distributions is what I've been talking about so far. They're a standard method for assessing environmental data and industrial hygiene data. The question is, are they too complex for us to use? And I don't believe so. The first thing you have to do, the first thing I had to do with Jack, is to get him to establish a database. If you're going to search for those properties with health complaints, you have to associate health complaints with a sample number, or visible mold, or water damage, or whatever. So you establish a database where you can search for all these parameters and compare them to fungal concentrations. So that's step one. That took him about probably 4 to 6 hours to get that done. After that, step two, let's say we want to look at 10 data points. We establish positions 1 through 10. We go into our database, we sort for those parameters, we select the data, we plot them. This is just in an Excel spreadsheet, for example. We take the positions, we convert them to percentages. Position number 1 out of 10 is 10%. Position number 5 out of 10 is 50%. So we generate the percentages. We associate the percentages with the rank ordered data from lowest to highest concentration, and then we plot it. So that's basically a 15-minute process. So if we want to know what the 75th percentile concentration is, it's about 25,000 for that example. Okay? Once you have this graph, you're done. You can use that in the next project and 10 projects.
And here's the values from the testing we did over the last couple of days. And it's really interesting here. This is the this is the 1 micron particle size channel, and it's by room, so each one of these is a room. Each one of these represents one of the rooms. Which one was negative pressure, which one was positive pressure, which one was positive pressure and HEPA filtered, and what were the other choices? Negative, positive filtered.
Negative and scrubbing and scrubbing.
And scrubbing, and one that was just scrubbing in the room but blowing it around back in the room. This is all going to be, I'm sure you're putting this all up online?
Oh yeah.
Okay, so this will all be up online. You'll be able to have more information as to which one is which. But the interesting thing, and the reason I put this up here, is I wanted to show you this because the way some of you are using this where you're going in and creating a baseline. Here, you walked in the room and you're creating a baseline. All right, here you're creating a baseline. We just set the instrument up, and I left it here. All right, so we're actually seeing some really good reduction. But then we come in to take readings, and we spiked our 0.1, or our 1 microns. And now look how long. It's literally, to get to the point where we were here, it's literally 8 hours to get to that point. And you can see the difference. This is when we had a room full of people, and this is when it was just Danny coming back in and checking things.
Some of them didn't spike much, if I'm reading it right. So like these red, yeah, there's a little...
No, this is, yeah. Well, that's because these are the larger, let's see, cleaner room. I'm going to have to see what 1049, that was one of the one to the far left.
It spiked in some rooms, but not all rooms, I don't think.
Correct.
Very interesting.
Yeah, I'll give you a copy of IMS so you can open these files with IMS,
Okay.
and then you'll actually be able to like zoom in on very specific spots on the graph and look at this, graphically.
Cool. What do you think, Luke? Pretty sweet, huh? We didn't have this the last couple of years.
But now this is really good because now that gave me ideas in terms of what we should do next year.
Yeah.
Remote as much of the interface out into the hallway. For my instruments, I'm going to make sure every one of mine, because I want to participate in this again, I want to make sure my instruments are all Wi-Fi enabled. I do have Wi-Fi on most of these, but not all of them had Wi-Fi.
So you could go like,
Yes,
all right,
Modbus.
when's the
But
ideal
through the
time to
Wi-Fi,
take...
Modbus to a PLC or to a Siemens or to any other kind of a monitoring system that can be tied through that wireless switch.
When's the ideal time to go in and do my final clearance if I want to make sure the lowest number of 2 micrometer particles, I'm going to go in there and sample at the time when the lowest number of 2 micrometer particles are airborne. Because most of your Aspens, if I'm not mistaken, Joe, are around 2 micrometers. They're the ones that are most commonly failing our projects. Aspergillus penicillium. Stachybotrys, I don't get, unless the guy's, a 1-4 person, then you'll see some failure on that. But in general, it's the Aspens. So we're focused on those 2s a lot when I do this work.
Now we want to get to the quantitative metrics with thresholds, okay, that separately provide early warning of possible future health-related or health-relevant dampness. Okay, so persistent water activity levels above 0.75 at the surfaces of organic materials or coatings. So this is water activity. How many know what water activity is, or you're familiar with that term and measure? Okay, so water activity is another term for it is available water. It's not the humidity that's in the air. It's not just the moisture content of a material. And it's how much moisture is actually available to the organism, typically on a surface. And you can look at moisture content above 80% equilibrium relative humidity in concrete or masonry, that, not just bare concrete, but concrete or masonry that is either coated with or in contact with organic materials and coatings. And of course, if you have high moisture in the concrete and you've got organic materials in contact with it, that is the food source then for, and it's not just mold, but it's also bacteria.